run out of time. Okay, so this was a good example of generic algorithm available in the arrays class. And remember, all I had to do was just say import and use it. This is the way you access this static method. You specify the name of the class that contains this method, and use fill. However, because the method is static, you never have to instantiate anything, right? So also make sure that this is not an array, but arrays. That's the name of the class, arrays. And we could jump to online documentation and read the documentation for the entire class. But we have sort of like a condensed version of this. Relational operators such as equal or not equal in this case. With respect to arrays, so if I say integer quantities, how about this? Let's try something like this. Apples and oranges. Great things to compare, right? Two arrays. As you see, both arrays are integer arrays. Both arrays, we can even start using initialization syntax and say 1, 2, 3, and in another one do exactly the same thing. 1, 2, and 3, right? Just create two arrays. What's going to happen if we say if apples equal oranges, then we can say system print apples oranges is true, right? Apples equals oranges is true. How about that? Okay. So we just do something like that, right? Just the whole idea is that, can we do this? Yes, no. Seems like we can do this. And what does it mean? Print line. Okay. So let's run this real quick just to see if we can get as far as that. So this never printed, so we can say else false, right? So we should be able to see this message on our string. So apples equals oranges is false. All right. So one more time. It never is too early or too late. Always just in time to be able to visualize what is going on. We create one array, right? We call it apples. Then we call another. When we create another array, we say oranges, and we populate exact same data in both. And we get this apples reference and oranges reference to these objects. And all of this is happening in our main local variable scope. And we have very successfully created two arrays, and we have references to them. The relational operators such as equal or not equal, like exclamation equal, those relational operators, they compare addresses. They compare address stored in a reference A to address stored in reference O. And of course, they're not the same. These are two separate objects. So that's why what we get is that apples does not equal orange. Apples does not equals oranges in this comparison. These are two physically different objects. Prior to the last version of Java, what we would have to do then, we'll say, all right, how can we write a method? Hopefully I have time to do this. Could we write a method which would allow us to do something like this? If we could say compare, compare oranges and apples, something like that. And, how about this? Instead of saying compare, say is equal. Apples, oranges. Or are equal. I don't know what. Are equal. How about that? So let's try this method. Static. Say public first to be consistent. Public static Boolean, right? Because we want to know true or false. Boolean are equal. And what should be the arguments to this call if we want to pass an array? Well, apples and oranges are arrays of integers. So we're just going to say int square brackets. That's the data type. This is an array of integers. And we say, I don't know, left. Another integer array will be called right. And then we say something like this, just out of the, the most straightforward approach. Index, integer index equals 0, which means start from the beginning, right? Then we say for index, as long as index is less than left a length. Length is a parameter, and also at the same time, as long as index is less than the right. Actually, you know what? Let's from the beginning. Let's simplify it somewhat. We can say if left or optimize. If left length does not equal right length, then we simply return false, because we would just assume that if arrays are not equal in length, they cannot be equal, right, in terms of the values that we want to determine. So now we can just use a very simple version of just if index is less than length, increment index on each of those, and then we can say in the loop if left, and we have an index to verify each element, does not equal right index. Immediately, without any other checks, return false. So they're not equal. We just found an element that's not the same. And only if we successfully get through this test, we can say return true, right? So that kind of says, okay, if that's the case, then apple, oranges, I don't know, we can just equal, and then we can also say this are not equal. How about this? Let's try this code, see if it works. Right? So they are equal. simply because they're both 1, 2, 3, 1, 2, 3. However, if I make them 1, 2, 3, 333, something like that, then if we run it, this works and it says they are not equal. Because programmers used to write this code in every application over and over and over and over again, of course, people realize, well, listen, this better be included someplace in the library so that this is equal approach to verify if the values inside of an array are indeed the same. Then what happened was that they decided to add the equals equals algorithm, which basically takes any array and will compare the values and uh, any primitive data types will be verified and compared and determined that they're equal or not equal. So that basically can be done. Let's see if this works well in our example. So we just replace r equal with array equal. So I can comment our custom version away, and instead of this custom method that I just wrote, use arrays equal. So same idea, give me two arrays and I will tell you whether they're equal or not. So if I run this, their apples and oranges are not equal as a result of that, right? So if I change this back to 3, expecting to be equal, and rerun it, then it says are equal. So again, we could write something from scratch. But if you, as a programmer, do something like this, let me just make sure I save this segment.